So hello friends, today we are going to learn about Kirchoffs basics law, which includes two laws. One is Kirchoffs Current Law and other is Kirchoffs Voltage Law. So how we will learn this? So first we will go through the statement of those laws, then we will try to understand the statement and we will understand with illustrative examples also. So firstly, what is statement? So what it states that algebraic sum of current meeting at a junction in a circuit is equal to 0. See, here it is important to mention algebraic. So let's say what is the difference between sum and algebraic sum. So say for example, if you go through this statement, so what is mentioned in this statement that we have to take a sum of current which are meeting at a junction in a circuit. So say for example, if we have junctions here and let's say if some current I1 I2 which is coming toward the junction and some current I3 and I4 going outside the junction. So if I only use the sum of current meeting at a junction in a circuit is 0, so it would be wrong. The reason is like if I directly take sum of I1 plus I2 plus I3 plus I4, this will not be equal to 0, right? If I only use sum of current meeting at a junction is equal to 0. So but when I say algebraic sum, so I have to be very particular with a direction of current. So if it is toward the junction, then if I am assigning plus toward the junction, okay, so minus should away from the junction. Okay, now if I apply this law, so I need to take algebraic sum, means I have to consider sign also while taking sum. So for I1 this current is toward the junction, so I will assign plus I1. Similarly for I2 plus I2, and similarly for the rest of the current which are I3 and I4, I will assign minus I3 and minus I4, and if I take sum, so this will become 0. So in other ways what I can also state that I1 and I2 two currents are incoming current while I3 and I4 are outgoing current. So if I further simplify this equation, so I can write I1 plus I2 is equal to I3 plus I4. So those are the incoming current. So the sum of incoming current is equal to sum of outgoing current. While you are writing this, you do not require to write like algebraic sum of incoming currents equal to algebraic sum of outgoing currents. So what you can simply write the sum of incoming current equal to sum of outgoing current. This is the alternative statements of Kirchoffs current law. So the alternative statements like current, sum of current flowing from a junction is equal to sum of current flowing toward the junction. So in the other way, like incoming current equal to outgoing current. So if you take a sum, algebraic sum of current at particular junction, so this will be 0. This is all about Kirchoffs current law. Now let's move to Kirchoffs voltage law. So first let's begin with the statement. So what is the statement of Kirchoffs voltage law? So here algebraic sum of voltages around a closed loop is equal to 0. So if in a circuit, if we have any closed loop circuit, so we need to take a algebraic sum of what voltages. So in any circuitry, what we may have is, we may have a voltage source, we may have the elements, okay, like resistors or other elements. Now while I have to go through this circuit, so I have to take algebraic sum. So algebraic means I have to consider signs also. So say for an example, in this very simple circuit, the polarities of voltage on the voltage source would be like this. So if current pass through this is like here, so and this is my resistor. We better know by applying Ohm's law, I equal to V over R. Now when I have to understand this Kirchoffs voltage law, so at that time I have to consider few things. Okay, so those few things are, say for example, if you are having one resistor, so let's say this is my resistor, and if current is entering from this terminal, see here it is important to understand that current will only flow, let's say this is A and B terminal, current will only flow from A to B if potential at A terminal is higher than potential at B. So it means that potential at A, if I am assigning a positive sign, so at other terminal I can assign negative signs, right? Okay. Similarly, let's say this is my battery, so plus and minus. Now there are two possibility. If current is inside the battery, so my battery is charging, and if current is away from the battery, then current is discharging, right? Alright, so now I have to apply the Kirchoffs voltage law and I have to take algebraic sum. So while I am taking any algebraic sum in a loop, so which are the things which I have to take care? So first thing which I have to take care is, let's say if I have a simple resistor like A and B, and if my current is flowing through this like this, okay, so my current travels from A to B, so I will assign positive here and negative here. Now I have to understand one thing. Let's say I am at this terminal, B terminal, where my potential is, let's say, 0 volt, and while I am traveling from B to A, so my potential increase, right? So if my potential increase, so let's say this is VR potential, as per Ohm's law I can give it as I, let's say this is R is the internal resistor, so V equal to IR. So this is the VR is the potential across this resistor. So if I am traveling from B to A, my net potential increase, so I will assign plus VR, okay. In the alternative ways, if my current flows from A to B, and while I am passing through these circuits, if my journey from A to B, so in this case my voltage across the AB would be like minus VR. Why? Because while I was on A point, so my potential was plus, and while I am going through this resistor, and when I reach on the B terminal, my potential becomes negative. So in this way this will become minus VR, okay. Similarly, if we have any potential source like voltage source, so if I am, let's say here capital A and capital B is there, so if I am moving from B to A, my potential changed from 0 to plus V, let's say this is V volt, so 0 to plus V, so my net potential increase. So if my potential increase, so it will be a positive. In the alternative ways, let's say this is V and this is A and B. Now if I am moving from A to B, okay, so at that time my potential will, so when I am on A and I am traveling to B, so while I was on A, so my potential was plus V, and while I will reach to B, so it will become 0, so my potential becomes plus V to 0, so it decreases. So understand the KVL with one example, okay. So say for an example, if we go with very simple circuit where we have one source in series with two resistors. So this voltage source is V and two resistors are R1 and R2. Now current flowing through this is I. Now here, as we mentioned earlier, that wherever current enters, so current will flow like this. So wherever current enters in any resistor, we have to assign positive here, negative on the other terminal. Similarly, positive here, negative on the other terminal. So while I will apply the KVL here, so I have to go through this entire circuit. Now let's say I am on this position, and if I move from this negative to positive, okay, so in this condition my potential increase. So because the previous potential, let's say this is ground, so the previous potential is 0 volt here, and this reached to this increased to plus V, so plus V. Now here current flowing through this resistor R1 and R2 are I, so here this voltage will be plus VR1 and this is VR2, so it is VR1 and VR2. So as per Ohm's law, we know that we can give it as a IR1 and IR2. Now while I am applying KVL, so what is the statement? If you remember, the algebraic sum of voltage in a loop is equal to 0. So while I was traveling from this to this terminal, so potential increase because I am traveling from 0 to plus V. Now if I further move in this direction, so here potential is plus V plus VR1, and then while I am moving from this to this, so potential will decrease. The reason is like previously it is plus V and then it becomes minus VR1, right? So when potential reduces, so this will become minus VR1. Similarly, at this point it is plus and at this point it becomes minus. So I am moving from plus to minus. So this is again potential reduced. So this is minus VR2. So this sum is something known as the algebraic sum. So algebraic sum will be 0. So if I substitute those things here, so this will be V minus IR1 minus IR2 is equal to 0. So V equal to IR1 plus R2. What is I? So V upon R1 plus R2. Okay, so in this way you can apply Kirchoffs voltage law and you can write the equations. Okay, so if we understand this law with one more examples. So let me add one. So here, let's say if we have circuits like this, okay, this is R1, R2, R3, V1 and V2, and loop currents are I1 and I2. Now here I have to apply KVL. So the current flowing through each elements I have to firstly identify. This is I1, this is again I1, and this is I2 again, I2, I2. Here again it is I2, this is I1 again. Will back. What is the current here in this? So this is unknown. So if I apply KCL here, so as per KCL, incoming current equal to outgoing current, or the algebraic sum of current meeting at a junction is equal to 0. So what are the incoming current? So incoming current are I1. And what are the outgoing current? Which is I plus I2. So what will be the I1 minus I2. Okay. Now if I want to apply KVL here, so firstly based on the direction of current I have to assign the signs here. So let's say here if I give terminal name AB, or let's say A1 B1, this is A2 B2, and this is A3 B3. Okay, so the potential available at A1 will be higher as compared to B1. The reason is current flows from A1 to B1. So here it will be positive, here it will be negative. Similarly, currents flow from A3 to B3. So potential at this will be plus and other is minus. Similarly here it is plus and minus. So if I apply KVL in the first loop, so if I am traveling from here to here, so potential increase from 0 to plus V. So that's why it is plus V1. Now if I am traveling from this A1 to B1, my potential changed from plus VR1 to minus VR1. So the potential reduced. So minus VR1. Here it is similarly minus VR2. Why? Because I am moving from A3 where potential was previously positive and then it becomes negative. So minus VR2. So this will become 0. So this is the first case. In the second loop, if I am trying to apply, so I am moving in this direction. So firstly I am on B3 point and then I will move to A3 point. Now at B3 the potential is negative and at A3 potential is positive. So my net potential increase. So this is my plus VR2. Now here while I am traveling from A2 to B2, potential decrease because here potential is plus V and here it is minus VR3. so it reduces, so minus VR3, and here the potential is plus V2, okay, and then it becomes 0 volt, so that's why it is minus V2 is equal to 0. So this is equation number 2. In this way you can apply KVL and you can work out what will be the algebraic sum of voltage.